So sequence, okay. So 3, 8, 20, 9, 20. Theorems on sequence only. Also yesterday we have the theorems. Sequence Sm is convergent then sequence mod of Sm is also convergent. That means also if sequence Sm is converges to L, then sequence mod of Sm converges to mod of L. So what the modulus theorem? Modulus. Proof. First of all, okay, we know we have this in mathematics. Mod of Sm minus mod of L always less than mod of Sm minus L. So these are the rules of mod of Sm minus mod of L. In general also, mod of A minus mod of B always less than mod of A minus B. This in mathematics. So this we use. So mod of Sm minus L is less than mod of Sm minus L. So this is given. So as sequence Sm is convergent, that is mod of Sm is convergent to L. Therefore, by definition, that is L is a limit of the sequence Sm. And then by definition of limit of the series, okay, we have what? For every epsilon greater than 0, there exists a positive integer m, okay, such a way that m must be greater than this your capital N. Then we have mod of Sm minus L is greater than epsilon. This is the definition of limit of sequence. Now one mod, so this used, so mod of Sm minus mod of L is always less than mod of Sm minus L, and this is less than epsilon by definition. So this will be less than epsilon. So mod of Sm minus mod of L is less than epsilon. Means what we know is this is the limit. Mod of L is a limit of the sequence Sm as n tends to infinity, or mod of Sm converges to mod of L. Converges limit. Converges is limit, and limit is converges. If there is a limit, we can say Sm converges to L. So it's simple proof. Okay, Sm converges to L. The mod of Sm also converges to mod of L. So it's simple theorem. Second theorem is called as a positivity theorem. Positive. Okay, see, statement is a positivity. Positive. This like let Sm be a sequence shows that limit of this Sm is L, and Sm is positive. All the terms of sequence are positive given the Sm. Then this L limit also positive. Okay. we prove this theorem. So let Sn be a sequence such that limit of this sequence is here. This sequence is L, and given to you every Sn term, S1 term, S2 term, S3 terms, every terms of this sequence is positive. So therefore, by way definition apply here. This provision limit of sequence. So for every epsilon greater than 0, there exists a positive integer m such that for n greater than m, then we have mod of Sn minus here is less than epsilon. That means, okay, we are using mod. So this means what? Sn lie between. We use the technique of mod. So Sn lie between left side L minus epsilon, L minus epsilon, and L plus epsilon. Okay. L minus epsilon left side and L plus epsilon right side. Okay. So this way. We use the less than greater than because I want to show positive. Okay. Now we have to show this here limit must be positive. Okay, we have to show. So we prove by contradiction method. We prove by contradiction method. Contradiction is contradiction, contract, okay, contract opposites. So we have to show A is a positive. We have to show. So we suppose it is a negative. Suppose that this here is a negative. L negative means L by 2 will be negative. L by 2 will be negative. Therefore, minus L by 2 will be positive. Sign change. L negative, L by 2 negative. Sign change. This okay. So, answer positive. Epsilon also positive. So we choose the value of this epsilon as a now choose epsilon as a dislike value minus L by 2. Epsilon also positive, arbitrary epsilon, you can take any values. Okay? Any values. So epsilon, you can say epsilon as a minus L by 2 choice. So from 1 now to here, value of epsilon. So L minus epsilon, epsilon is minus L by 2. Less than Sn, less than L plus epsilon is what? It is a minus L by 2. So minus minus plus. So 2L plus L by 2, 3L by 2. L minus L by 2, L by 2. So your Sn okay, lie between 3L by 2 upon and L by 2. From this I want this side. So Sn is less than L by 2. What is strictly also lie between. So Sn lie between. So Sn is less than L by 2. And L by 2 is a negative. That means Sn will be negative. This is less than 0, negative. So Sn will be negative, which is contradiction. The given that, okay, which is contradiction. Okay, that is what assumption is wrong. We assume that L is a negative is wrong. So our assumption, supposition is wrong. Okay, so what is right? We assume it is a negative is wrong. That is what? Here is a positive. Equal to 0 also. Okay, so this is a theorem. limit of Sn is here. Sn terms are all terms are positive. Therefore, limit also positive, never negative. Next theorem is also called as a sandwich theorem. Sandwich theorem. See this next statement. So let Sn, Pn and Un are the three segments. Such that number 1, Sn less than Pn, Pn less than Un. Means Pn lie between Sn and Un are all natural numbers. And second point is a limit of Sn and limit of Un is L. Limit of Sn is L, limit of Un is L, then limit of Pn also L. That is understood. Limit of Pn also L. So then lie between these so if sequence Sn, sequence Pn and a sequence Un be three sequences such that first point Sn less than Pn less than Un, and second point is limit of Sn and limit of Un is L. Then limit of Pn also here. Sure. So limit of Sn is here, limit of Un is L. Apply definition. Limit of sequence. So definition. So for every epsilon greater than 0, there exists a positive integer m always, but I want here 2 times, so m1 I use first for first m1 for the Sn m1 and m2, such that n greater than m1, then we have mod of Sn minus L is less than epsilon. That means what? Sn is lie between L minus epsilon and L plus epsilon. M1 and M2 also. Both times we use. Also for second, for n greater than M2, then we have mod of Un minus L is less than epsilon. So for first M1 and next also second M2. That means what? Okay. Un is lie between L minus epsilon and L plus epsilon. So this combined equation. Now here M1, here M2, so I have only single M, so let M is a maximum of these two numbers, M1 and M2. Okay, so for this M, equation number 1 is true, will be true, both. So comes to prove now. So from 1 and given to you. Okay, so L minus epsilon, L minus epsilon less than Sn, but Sn less than Tn, Tn less than Un, and Un less than L plus F1. So combine both these two and it's given to you. Okay. I want proof for Tn, only I use Tn. So Tn will be lie between L minus epsilon and L plus epsilon. I want proof for Tn. For Sn and Un given to you, no problem. So only Tn. So Tn lie between this is what? What is the meaning of this? Mod Tn minus L is less than epsilon. This is this, this is this. Okay. Tn lie between L minus epsilon. So mod of T minus L is what? Limit. Here is a limit of Tn. So limit of Sn is L, limit of Tn is L, and this lie between, then limit of third also L. So sandwich theorem. So what is sandwich? Actually, this is sandwich वाले scientist. Sandwich. Take small example on this sandwich. Then we stop. Show that limit of sin n upon n is 0. Sin x upon x tends to 0, 1. But here infinity, n tends to infinity. Then I want it 0. Sandwich theorem lie between. I want to lie between two values. So we have in mathematics every sign value is lie between -1 and +1. Okay. Sin 90 1, sin -90 -1, sin 0 0. Every values lie between -1 to 1. Energy is 1.5 or 2, 3, 4, 5, 6. Every value lie between -1 and 1. 0, -1 and 1. Every values. If you take any angle, sin 30, sin 60, any angle, sin values. Okay. So I want sin n by m divided by m. So this lie between this and this. Now denote let this suppose say Sm. This suppose say Tm as theorem. This suppose say Un. Now limit of Sn and Un, limit Sn as n tends to infinity minus limit n tends to infinity. So 1 upon infinity 0. Limit of Un, one upon infinity 0. Okay. So limit of Sn is 0. Limit of Un is 0, and this is lie between 2. Okay. Yes. Sn lie between Tn and Un. So limit of Sn is 0. Limit of Un is 0. So limit of Tn is 0. So by sandwich theorem. So limit of that Tn is also 0. So this Tn, limit of sin n upon n, n tends to infinity. So this is sandwich theorem. Lie between, okay, two values.